Okay, so today we are working on word problems for Pythagorean Theorem. Again, this is still pretty much mostly pre-algebra. So there's some pretty standard word problems that we end up with. Just to remind you that our legs, if we square the legs, if we square each leg and add them up, it will equal the hypotenuse, the longest side, squared. And we use what's called a squared plus b squared equals c squared, the Pythagorean Theorem. Okay, that's just a review. Sometimes we might be given actually either a right triangle on a grid, or we might be given a diagonal line on grid paper. You guys with me? Mm-hmm. And if that's the case, we can create a right triangle to help us figure out. We can't count our diagonals here because you can see that right here, that's not a whole square. And this isn't a whole square. And this isn't a whole square. Do you see how the sizes vary? So we can't really count our diagonals. But what we can do is take our vertical and horizontal, create a right triangle out of that diagonal, and then if we're on 1 centimeter grid paper, we can count those boxes. That's a complete box. 1, 2, 3, 4, 5, 6. So that's 6 centimeters, since this is centimeter grid paper, right? And this is how many?
9.
Count them. Don't guess. Math is not a guessing game. Look, and I'm writing what you wrote too. It's not a guessing game. It's proven, right? So now if I count my horizontals and my verticals, then I can use that to figure out what my diagonal, by substituting that all into the Pythagorean theorem. A squared plus b squared equals c squared. Does anybody recognize these numbers? Does anybody know off?
64 and 36.
Yeah. Know what the diagonal is just by looking at this. It should be 10 because it is a Pythagorean triple. If I divide both by 2, I end up with 3 and 4, and a 3, 4, 5. There's the 3, 4, 5 triangle. So I take 6 squared plus 8 squared, and we get x squared, our unknown, right? And then I get 36 plus 64 equals x squared. It's 100 equals x squared. We root both sides, and 10 is equal to x. Or the negative 10, but we know it can't, negative 10. We know that it can't be that because measurement can't be negative. So are there any questions here on how to use the grid paper? Now, sometimes they might even just give you the full triangle. But sometimes they might just give you a diagonal, and then you can create right triangles using and find the diagonal by using your Pythagorean theorem. Okay? Do you remember that Pythagorean triple, 6, 8, 10? Mm-hmm. Yeah. It's just 3, 4, 5 doubled. Okay, so I'm going to give you one, and let's have you solve the next one. Go. Pause the recording. All right, so what do we get for the left side? Anybody? Go.
We got 4 squared.
Okay, we got to have a 4 over there, and we have, what do we have for the bottom?
7.
A 7, and so when we're substituting in, what do you substitute?
It would be 4 squared plus 7 squared equals 6 squared.
Yep. And when you simplified, what'd you get?
16 plus 49 equals c squared.
Good.
65 equals c squared, and then root it, it would be 6 is about 8.4.
Okay, so we can either do reduced radical or estimated. Okay. But we definitely don't use the negative. So if we estimate it, it comes to about 8.1. It's very close to 64, so that's an easy one to estimate. Questions? Okay. On this one, it says, find the missing side of the right triangle. Well, actually, we're able to figure this one out, so I'm going to skip this one. And by now, you should know the square root of 169 is?
13.
Good, finally. I feel like my kids are learning it. Okay. Somebody asked me, do they always give you A and B? No, they might give you C. So in this case, we would just substitute A. What's given here is A and C or B and C. I still use my Pythagorean Theorem. And then when I do that, we can subtract 16 from both sides. And I get x squared is equal to 84. Now we can do one of two things. We can reduce the radical. So what divides into it evenly that's a perfect square?
4.
8's not a perfect square. 4. 4 and 21. And so that simplifies to 2 rad 21. Good. 2 rad 21. Now, if you look at my PowerPoint, sorry, they estimate it to about 9.2, but I would be happy to accept 2 rad 21. Got it? Questions? All right, can I skip this one? I want to go on to some word problems. All right, find the measure of the diagonal for a rectangle that measures 3 inches by 4 inches. So what is a diagonal? Does anybody know? I see you're showing me with your hands. Can you clarify?
It's sort of the line that goes in between a rectangle that divides it in half.
And it goes corner to corner. Right. So we're drawing a line corner to corner. We've got the two sides. Does anybody know what the answer is right now before doing any math?
5.
5. Why? Because it's a Pythagorean triple. So we can substitute in 3 squared, 4 squared, and 5 squared. And we get, right? Okay. Let's keep going. Okay, find the length of a side of a square whose diagonal is 4 meters long. Okay, so I'm drawing my diagonal. The diagonal is 4 meters long. What do they want?
They want a side.
And what other piece of information are they giving us?
It's a square.
It's a square, so what does that mean?
Both sides are the same. All
Same.
sides are the same.
So did they give us 2 sides and we have to guess the third?
No.
No, but if they're the same, okay, you got to stop. If they're the same, you, right, we call them x. Does that make sense? And then we can substitute in x squared plus x squared equals 4 squared. Questions? And what do we get? What is x squared plus x squared? 2x squared equals 16. Divide by 2. This would be a good one to write down. And we get x squared equals 8. Now what? What are we doing?
Find the square root of both.
Root both sides, and we get x is equal to, break down 8 into 2 rad 2. Good. 2 rad 2. We could say that that's made up of a 4 times 2, which becomes that. Or you could estimate it. X is about equal to, it's almost 3, but not 3. So I'm going to say about 2.9. And the square root of 8 is 2.8. So I'm pretty close. Okay, questions? All right, let's move on. Just kind of showing you different kinds of scenarios that they could set you up with. To the nearest tenth of a foot, find the length of the diagonal of a rectangle with a width of 4 and a length of 10. Tell me what to draw. What am I drawing? Yep, I'm drawing a rectangle. Okay. And what else do I need to draw? A diagonal, okay, go diagonal. Okay, now how am I labeling it?
You'll label the width 4 and the length 10 and line the diagonal line.
There we go. And so we're doing 4 squared plus 10 squared equals x squared. 16 plus 100 equals x squared. 116 is equal to x squared. Remember, what's the closest square to that? 121, right? Yeah. So that would be 11. So this is about 10.7, 10.8. Or I could divide it. 4 goes into 116 how many times? 2. It's 8. 29. So I could break that down to 4 times 29 equals x. Don't be rude. Let's do that. And so we're getting 2 red 29 equals x. Or, now I could find the square root of 29, or I can just find the square root of 116. I think finding the square root of 116 is a little bit easier. So I could say x is about equal to, it's less than 11 but greater than 10. So I would say like 11.8, 10.8. Let's see, let's check that. The second square root of 116 is 10.7. So we should be able to get there within 1/10. Are there any questions? Pythagorean theorem really doesn't change much from 7th grade. The difference from pre-algebra, the difference is that we add radicals to your Pythagorean theorem. So you might have to square a radical. Or a lot of times we'll use big numbers, but I think big numbers were used in Pythagorean theorem in pre-algebra as well. All right, so now we're going to draw the situation that happens. A car drives 20 miles due east. Okay, that's 20 miles, and then 45 miles due south. To the nearest 1/10 of a mile, how far is the car from its starting point? So what it's creating for us is this nice right triangle, you know? That's the closest point way back to the starting point. So here is your right angle. The distance back becomes your hypotenuse. Okay, questions? And then we do something like, 20 squared plus 45 squared equals x squared. 20 squared is 400. And 45 squared is 2025. Add them together, and we have a pretty big number. Now, let me show you how to narrow that down. I'm going to narrow it down to about 2 numbers.
25.
Huh?
25.
Well, 25 squared is 625. So, no, it's not that. But look, if I'm at, we know that, okay, let's go to 40 squared. What is 40 squared?
4,000? No, wait.
40 squared
1,600.
equals 1,600, right? And let's go 50 squared.
2,500.
Okay? So we know that it's less than this. In fact, it's very close to the 2,500, right? So right now, I've already done the math for 45 squared. So I know it's bigger than 45 squared because I did that math already. I multiplied 45 times 45. So that is 2025, right? And we're looking for 2425. So what's your best guess?
48.
48 squared or 49 squared? Now, what I have done is I have figured out of all the numbers out there, that this is between either 48 squared or 49 squared. And I think it's going to be 49. 49 times 49 is 2401. So it's a little bit more than 49 squared. 49 squared is, what did we say? 2401. So what's your best guess there?
49.5.
It's about 49.5. You think it's halfway between?
Maybe 49.7.
Okay, hun, 49 squared is 2401. This is 2425.
Oh.
50 squared is 2500. You said it was 49.5. That means that 25 is exactly halfway between 2401 and 2500. Then you went higher. So what's your best estimate? I like 49.3. 49.2, 49.3, I would accept. You could also divide this by 25, right? 24, 25. So it goes into about 255 times. It's going to be less. It's going to be 4, right? Because no, not 5. It'll be 8, 9. It'll go 9 times. Because 8 times is 200. So that's why I'm going to 9, not 10. So 9 times 5 is 45. Carry the 4. It goes 18 and 4 is 22. And we have 7, and that becomes a 3. So 1. Okay, and this goes how many times? Let's go 4, 5, 6, 7. Yep. So this could be broken down to 25 times 97, which would be 5 red 97. Are you guys with me? Mm-hmm. Or we estimated it too, and what is that? What? 49.3 about. We're pretty close. So, do you understand how to deal with the big numbers?
Yes.
Okay. Oh my. All right, so now it says find the legs of a right triangle if one leg is twice as long as the other. What are we going to do?
I just had one question about this problem before. Could you have found a perfect square that divided into the number and then done like whatever the number rad of another number and then just keep simplifying it?
Yeah, so that's what we did right here.
But
I could have done 5 times, this is less than 10, so about 9.9 times 9.9, right? In fact, let's see, second square root of 97 is 9.8. I'll do that times 5 is 49.2.
okay.
I could have done it that way. The only reason why, well, we did do that. We broke this down. I knew 25 went into it. So that was the perfect square. I did 25 goes into it. Remember I did the division? And I got 97. So that's how I got the 25 times 97, which is 5. I'm sorry, this should be 97. 5 rad 97.
Okay.
That's how I got that. Okay. Next problem. Find the legs of a right triangle if one leg is twice as long as the other and the hypotenuse is 10 centimeters. What are we going to call the first leg? What? X. And what do we call the second leg? 2x. So what's my Pythagorean theorem going to look like?
X squared plus 2x squared equals 10.
Plus the quantity of 2x squared.
2x squared.
Right. Remember, the 2 is squared as well, not just the x. So what does that simplify to, that 2x squared?
4x squared.
And then when I simplify, what does it become?
5x.
5x squared equals 100. Divide by 5. And x squared equals 20. We could take the 4 out, would be 2 rad 5. Or 4.4. Okay, questions?
Can you view it? X equals rad 2.
No, you may not. You must reduce the radical, do 4 times 5, and that becomes 2 rad 5. Reduced radical or estimation. Got it? Okay, questions? Oh, and when they're looking for both sides, remember, we've only found one side. So that would be 4.47. So if I double that, that gives us the other side because they want both legs. Do you understand that I did not just finish finding both legs just by solving using the Pythagorean theorem? Does that make sense? Okay. All right. So the ladder problem. That's all. They always have the ladder problem. They take the ladder. I've got a yardstick here that I'm using as a ladder. They lean it up against a wall and they create a right triangle. Okay? The ladder is generally seen as the what? Hypotenuse. And the wall and the ground are the legs. Okay? So we just label the different parts. It's a 12-foot ladder. Is leaning against the wall. How far must the base of the ladder be placed away from the wall if it's to reach a height of exactly 10 feet? So what?
The height should be 10.
The height is 10 and the ground is unknown. So then we're doing 10 squared plus x squared equals 12 squared. 100 plus x squared equals 144. Subtract the 100. X squared equals 44. I could root both sides, and we get x is equal to, how about 4 times 11? So x equals 2 rad 11. If I know the square root of 11, I can multiply that times 2 too if I need to estimate. Or the square root of 44 falls between what perfect squares? 36 and 49. This is 8 units away, and this is 5 units away. 6.6, 6.7, 6.8. Estimated to be somewhere in there. Questions? Okay. All right. Another one that they like to use is like a flagpole with a wire hanging down. Okay? A guide wire is needed to support a 20-foot pole. How long should the guide wire be if it's to be fixed to the ground 8 feet from the base of the pole? So I'm just drawing, I'm just labeling the different parts. The pole is how much?
20 feet.
20 feet. What is the 8? Where do I put the 8? On the ground. And so we're wondering, how long is the wire? And every time they put us into a... Notice that each one of these, they're not saying use the Pythagorean theorem. So on a final, this would be mixed around. You're going to have to draw the situation and say, oh, we've created a right triangle. That means it's time to find the... we're going to use our Pythagorean theorem. Does that make sense? Yes. 464. Well, 4 goes 108. I think it goes, does 4 go into this 108 times? 464 divided by 4 is a 116. So it'd be 4 times 116. So how about 8 goes into, let's go 16. Yep, 16 times 29. 16 goes, so it'd be 4 rad 29, or we can estimate it to about, remember 21 squared is what? 441, and 22 squared is 484. So we know it's somewhere in between, almost exactly in the middle. 464 between 441 and 484. All right, next one. So find the value of x. Now, what you have to understand is it's your job to create right triangles so you can find this diagonal. So let's label a couple of different things. If this side is 6 inches, isn't this side 6 inches?
Yes.
And if I draw a line from here to here, then I have, isn't this a right triangle? Whoops.
Yeah.
Yeah.
I think here's the right triangle, right here,
6 and 8.
right? So I'm drawing that line. I know that that's 6, and I know that that other line, can't we say also that that's a 5?
Yeah.
Right? Because they're parallel. These are parallel, so I can call that 5. And we know that this one is,
5.
that this over here is our 6. You with me?
Yeah.
And where the corner of the box meet, isn't this the right angle?
Yeah.
We know that. So that y has to be the hypotenuse for the ground triangle. Do you see I created a triangle on the ground only because I need to really find this x. So now I've got a squared plus b squared equals c squared. 6 squared plus 8 squared equals y squared. 36 plus 64 equals y squared. 100 equals y squared. So what is y?
10.
We know that y is 10. Now what I have is, I have this, I have this. So now we have the ability to find that diagonal of the three-dimensional box. 5 squared plus 10 squared equals x squared. 25 plus 100 equals x squared. 125 equals x squared. And we can say, oh, I should have really split that up here. 5 times 25, right? And we end up with 5 rad 5 equals x. Or we can do square root of 125 is about 11.2 or 1. 11.2 or 11.1. The one thing I want to say is that reduced radicals are far more accurate in science and math. People don't usually like you estimating. So unless you have to order some material from the store, that's when we have to estimate. Okay? Questions? How do you feel about that one? All right, that's our lesson. 11.8.